In mathematics, we run across a lot of Greek letters. In Algebra 2, when we studied statistics, we ran across this for mean. It was the lowercase Greek letter sigma. Well, today we're going to talk about the uppercase Greek letter sigma. In mathematics, the uppercase sigma, which looks like a big giant E, stands for summation. And summation means addition. So sometimes this is called sigma notation, and sometimes it's called summation notation. The way it works is you're going to see a number below the sigma and a number above. These numbers are going to get plugged into a mathematical expression, and each term of the expansion is going to get added together. So in example 1a, we're going to plug every number starting at 4 and ending with 7 into this expression. So we're going to plug in 4, 5, 6, and 7, which means we're going to get 4 terms. So we're going to start with 3 to the 4th plus 1. We're going to add it to 3 to the 5th plus 1. And then we're going to add it to 3 to the 6th plus 1. And then we're going to add it to 3 to the 7th plus 1. Well, let's actually go find each of those values. 3 to the 4th plus 1 is 82. 3 to the 5th plus 1 is 244. 3 to the 6th plus 1 is 730. And 3 to the 7th plus 1 is 2188. And when you add those 4 numbers together, you get 3244. This is called expanded form. And then we added them up, we got 3244. Now there is a shorter way of doing it, so we're going to talk about the shorter way of doing it. But this is how it works via expansion. All right, I'm going to erase this and talk about how to do it on the graphing calculator. Now it depends on which type of graphing calculator you have on how you're going to do it. So if you have a TI-83 or a TI-84, but it has the old operating system, the way that you're going to plug this in your calculator is you're first going to go to Second Stat. This is the list menu. And then you're going to arrow 2 to the right to Math. And you're going to enter number 5, which is Sum. So on your screen, you see this. Then you're going to go back to Second Stat again. But this time you're only going to arrow 1 to the right to Ops, which stands for operations. And you're going to go to number 5, which is SEQ. That stands for sequence. So what this is going to tell the calculator is that we're going to add up a bunch of numbers in a sequence. But now we have to tell it what the equation is. So at this point in time, the next thing you're going to do is you're going to plug in the equation. You can use the letter B if you want, because you know you have the alpha letters on your calculator, but you don't have to. You can just use X. You can do 3 to the X plus 1. So the first thing you do is you put in your expression that you're going to plug numbers into. And then use the comma button. The comma button is to the left of the parentheses button. After you put in the expression, you have to tell the calculator what variable you're using. So if instead you had decided you wanted to use B, you'd tell the calculator, B is my variable, comma. The next thing you do is you tell the calculator what number you're starting with. You're starting by plugging in 4, comma. And then you tell the calculator where you're ending. You're ending with the number 7, and then comma. And then the last thing you're going to do is you're going to put in a 1. What that stands for is step. It basically says you're going to plug in 4, 5, 6, 7. If you make this number a 2, it'll go 4 and then 6. If you were to make that number 3, it would plug in 4 and then 7. So you always want the step to be 1. And then you close the parentheses, you hit enter, and 3244 pops up. If you have the newer operating system, I'm going to get rid of this. You still go Second Stat to Math and then call up sum and second stat ops and call up sequence, but then a different screen pops up and it actually says like expression, variable, start, end, step, and then paste. So in here, you would put your 3 to the x plus 1, then you would put x, and then you would put 4, and then you put 7, then you put 1. When you paste it on the screen, it'll actually look like what it does if you're doing this on an older calculator. And then you hit enter, and 3244 will pop up. So now, get rid of this. Now you can do the other problems much faster by plugging them into the calculator. Now, warning, some of you on the newer calculator, if you go to Math 0, will have a summation function. Not everybody has it, but if you press the math button and then press 0, you might get a blank sigma with a bunch of places where you can plug things in. If you do, then you could go put x here and then arrow to the right and put in 4, and then arrow up so you can put in 7, and then arrow to the right again, and in the parentheses you can put your 3 to the x plus 1 and then hit enter. And that will also result in 3244. So I should have hit all the bases of people who have different types of calculators. If you have an older calculator, it's going to look a little bit different on your screen, but either way, the answers always end up being the same. So now, when you do these problems, B should end up being 224. C ends up being 30. Now let me write my 3244 here. And D ends up being 84. So try those out on your calculator and make sure you get those answers. If you forget how to plug it into your calculator, rewind the video and go back and look for the instructions and write them down. Now let's look at these 4 problems. Well, how do I plug this into my calculator? There's a little infinity symbol. Where's the infinity on my calculator? It's not there. These problems are a little bit different. They are infinite geometric series. Wait a second, we just talked about infinite geometric series in section 12.3. Remember, an infinite geometric series is one where you find the sum by doing the first term divided by 1 minus r, as long as r was a number that was less than 1. So, how do I know this is an infinite geometric series? Well, because if I start plugging numbers in, so when n is 1, you get 2 times a third, which is 2/3. When n is 2, you get 2 times 1/3 squared, which is 1/9. So it's 2 times 1/9 is 2/9. And then when you plug in 3 for n, 1/3 to the third power is 1/27, so you get 2/27. And if you plug in 4, you get 2 times 1/81, which is 2/81, and I'll stop there. So that's definitely not arithmetic. How do I know if it's geometric? Well, if you check the second term divided by the first term, you'll get 1/3. If you check the third term divided by the second term, you'll also get 1/3. That means we're multiplying by 1/3. So that number that's in the parentheses, that's the common ratio r. So, infinite geometric sequence. How am I going to find the sum of this? So now I know r is 1/3. But in order to use the formula, I've got to find the first term. How do you find the first term? You plug in the first number here, and that'll find you the first term. And we said 2 times a third to the first power was 2/3. So the sum is going to be 2/3 divided by 1 minus a third. When you go put this in your calculator, I would put parentheses around this, and you'll get 1. All right, let's do this again. Over here, the common ratio is 5. But what do we say about infinite geometric sequences? The common ratio has to be less than 1 in order to find the sum. So, no sum exists. Let's go down to the next one here. The common ratio is 4, but that's too big. So no sum exists. Let's go to the last one. In this one, the common ratio is 1/4. Oh, that's good. It's less than 1. That means I can find a sum. Well, first I need to find A1. Well, since the number below sigma is 1, that's the first number we plug in, so 28 times 1/4 to the first power is going to be 7. So the sum is going to be 7 over 1 minus 1/4. Don't forget to put that in parentheses. So the answer is going to be 28 over 3, or 9.3 repeating if you leave it as a decimal. And that's sigma notation in the nth term.